When an AI agent can move money, call contracts, or approve actions, safety is no longer optional. Before we give agents real tools, we need guardrails, approval gates, secure execution policies, and defenses against malicious prompts. So far, we've moved from simple chatbots to agents that can reason, choose actions, call tools, and manage multi-step workflows. That power changes the safety model. Once an agent can touch APIs, data, scripts, or wallets, guardrails define what it may do, when it may do it, and under whose authority. A text model can be wrong. A tool-using agent can act. It can move money, change data, trigger workflows, or carry forward bad instructions. That is why safety has to be built into execution, not just added as advice around the model. A useful starting point is to separate safety failures by what they harm. Authorization risk is about consent. The agent acts without approval. Financial risk is about value. It spends, transfers, or trades incorrectly. Data risk is about exposure, secrets, or user information leak. Manipulation risk is about influence. Malicious content steers behavior. Each category calls for different guardrails, so taxonomy comes before tooling. For sensitive actions, the safest agent is not the fastest one. It is the one that pauses. Before moving money, changing permissions, signing contracts, or deleting data, the agent should explain the proposed action in plain language, what it wants to do, why, and what should happen next. The human decision must be explicit and recorded. Only after approval should the tool run, with a clear log of exactly what was approved. Confirmation should match the risk. If an agent is only reading public data, it should not interrupt the user. If it is preparing something consequential, like a transaction, approval may depend on context, permissions, or repeated usage. When the agent can sign, send, move funds, or change critical state, require explicit confirmation. Good systems make these thresholds configurable as the application's risk changes. Approval only works when the person understands the consequence. Don't ask, approve this action. Show the action, target system, amount, recipient, network, and reason. Include the agent's confidence, plus any risk flags or policy warnings. Whenever possible, show the before and after state so the impact is concrete. Keep it concise but plain. The goal is informed consent, not a rubber stamp click. Policy-based execution turns safety from a suggestion into an enforcement layer. The agent can propose an action, but the policy engine decides whether it is allowed, blocked, or needs escalation. These checks should cover concrete rules, such as spend limits, approved chains, valid contract addresses, and restricted operations. The key is that the agent cannot reason its way around them. Policies run before tool use and again before final submission, with every decision captured for auditability. Once an agent can move money, trust needs hard boundaries. A good wallet policy answers 4 questions before any transaction executes. How much can it spend? Who can it pay? Which networks can it use? And what is the total daily exposure? These rules turn vague permission into enforceable constraints. The agent may still act quickly, but only inside a predefined financial sandbox that is specific, auditable, and easy to revoke. Policy checks should not be treated as a single yes or no gate. Sometimes the answer is yes, the action satisfies requirements and can proceed. Sometimes it is no, a hard rule is violated, so execution stops. Many cases sit in the middle. If an action is unusual, sensitive, or high impact, the safest response is escalation. That preserves usefulness while making sure ambiguous or risky decisions get human judgment before the agent acts. Prompt injection is a fake command hidden inside ordinary content. An agent may think it is reading a website, proposal, token description, or NFT record, while the text contains instructions like ignore your rules or send funds. The defense is to separate data from authority. External content can be summarized and analyzed, but it must never override system instructions, reveal secrets, or trigger tools unless trusted checks approve the action. In Web3, prompt injection often looks like normal blockchain data. An NFT description, token field, DAO proposal, transaction memo, contract metadata, or linked website can all contain text that tells an agent to ignore rules or take unsafe action. The key point is simple. On-chain does not mean trusted. Treat every external string as untrusted input. Isolate it from system instructions and require validation before it can influence decisions. Strong prompt injection defense starts with separation. Keep system and developer instructions distinct from user requests and retrieved content. Treat anything from the outside world as untrusted data, even when it looks like instructions. Then constrain what the agent can do with structured tool calls, allow lists, validation, and sanitization. For high-impact actions, the final decision should come from policy checks or human approval, not from the model's judgment alone. Log suspicious attempts so defenses can improve over time. Treat safety controls as production features, not decoration. Before an agent gets real permissions, test the failure paths. Denied approvals, spending caps, blocked addresses, unsupported chains, and malicious instructions hidden in external content. Then make every decision traceable. Log the plan, policy check, user approval, tool call, and outcome. In production, monitoring closes the loop by flagging repeated denials, unusual spending, or behavior that differs from normal operation. Agent safety is what turns useful automation into trustworthy deployment. Keep humans in the loop for irreversible or high-impact actions. Use policies to limit spend, contracts, and chains. Treat external content as hostile by default. Next, we'll build the blockchain foundation: wallets, keys, signing, and on-chain data.